universe is huge, so huge that the human brain struggles to comprehend its true size. In order to even begin to understand the size of the cosmos, you need a way to help your brain process the information it's receiving. Let's start close to home. Let's start in Earth's orbit. The International Space Station. It's about 400 kilometers up. That's 254 miles. The space station is the size of an American football field and is moving around the Earth at a speed of 17,500 miles per hour. That means the space station completes an orbit every 90 minutes. The space station is in what we call LEO, or low Earth orbit. This is the lowest point an object can remain in orbit stably, but we have satellites that go all the way out to geosynchronous orbit, which is 40,000 kilometers away. That's 22,000 miles, and that's almost the distance around the entire Earth. It's when we move away from man-made satellites that we find the moon, and that's when the brain really starts to underestimate the distances of space. I mean, after all, it only took 3 days for astronauts to get to the moon. How far away can it really be? Well, it turns out the moon's actually 240,000 miles away. And the brain really struggles to figure out how far that distance truly is. To understand that distance, we need to shrink to a scale of 1 to 190 million. At that scale, our Earth is the size of a tennis ball, and our moon is this, just bigger than a paintball. Before I show you how far apart our papier-mâché moon and tennis ball Earth would be, I want to know what people already think. So I asked some of my classmates to show me how far they think the moon would be from the Earth at our scale.
If I had to guess, I'd say the moon and the Earth are probably about this far apart.
Well, our moon would actually be all the way over here, 7 feet away. If we move back to the real distance of 240,000 miles, we find that every planet in our solar system can fit in between the Earth and the moon, even Pluto, as shown by the YouTube channel Corridor Crew in their video about the same topic.
Next to Earth, we would put Mercury, Venus, and Mars, and then expand outwards to Jupiter, followed by Saturn, and then Uranus and Neptune. And you could even throw little Pluto in here for good.
This really shows that even though the moon is close to us in the scale of the universe, it's still quite far away. Far enough away that even light takes some time to reach it from Earth. But if we take a big step back into our cosmic backyard, we find our solar system. Now, at this size, our kilometers and miles won't help us anymore. The brain just can't understand that big of numbers. So, we have to introduce a new form of measure, the astronomical unit, or AU. The astronomical unit is the average distance between the Earth and the Sun. That equates to 93 million miles. Using this measure and Pluto as the edge of our solar system, it stretches an astounding 80 astronomical units in diameter. That equates to over 7 billion miles. And that's not even the full extent of our solar system. We have asteroid fields that extend out much farther, all the way out to 1,920 astronomical units in diameter. Even Mars, which NASA plans to send humans to in the near future, is on average more than an astronomical unit away from Earth. Despite this, humans have sent multiple rovers and satellites to Mars. But Mars is not the furthest humans have explored. That title belongs to the satellites that we launched in 1977.
We have ignition and we have liftoff. We have liftoff of the Titan Centaur carrying the first...
These satellites are the Voyager 1 and 2. Voyager 1 is the furthest along as it flies through space at a speed of 38,025 miles per hour. That's 11 miles every second. Voyager 1 is 147 astronomical units away from Earth, and that makes it the first man-made object to reach interstellar space. To continue even further past that, we need to add yet another form of measure to our catalog, the light year. Many people are familiar with the light year, and as the name suggests, it's the distance light travels in one Earth year. That makes 1 light year 6 trillion miles. That is a 6 with 12 zeros after it. And with our light year, that makes the closest star to Earth, Proxima Centauri, 4 light years away. And just to understand how far away that really is, our Voyager 1 spacecraft would take 40,000 years to reach it. Now, distances aren't even the craziest part about our universe. That title belongs to the size of some things in our cosmos. And if you want the biggest things in the universe, look no further than stars. Our own sun could fit the Earth 1.3 million times inside of it. And our sun is nowhere close to the biggest star out there. Now, our sun's not small. In fact, it's bigger than 80% of other stars, which are red dwarfs. But that other 20% that's larger gets much larger. Let's start with the star Sirius. It is 25 times more luminous than our own sun, and it's the brightest star in the night sky. And then size. It's 10 times larger than our own sun. But even Sirius looks tiny put next to a star like Rigel, which is 70 times larger than the sun. But unsurprisingly to anyone, there's even bigger stars than Rigel. Look no further than stars like Betelgeuse and Antares. Betelgeuse is a ginormous 700 times larger than the sun. Betelgeuse is what we call a red supergiant. This is similar to what our sun will become at the end of its life. Our sun's going to become a not so super red giant, and it'll extend all the way out to the orbit of Earth. But every star looks small compared to the largest star we've found. This star is incredible. It stretches out to be an astounding 1,700 times larger than our sun. And this star's name is UY Scooty. So as you can see, we're really small. That's pretty obvious at this point. And the craziest part is that with everything I've talked about today, we haven't even left the Milky Way, our galaxy that is home to 100 billion stars, and it's just one galaxy among billions. The universe is amazing, and we can only imagine what else is out there that we haven't yet discovered. Just look at this picture. This is taken by the Voyager 1 spacecraft from the orbit of Neptune. That pale blue dot suspended in that beam of light, that's Earth. So if you ever want to see something incredible, look no further than up.